Question number 7, ChemWiki, Thermodynamics, and Work. A gas is allowed to expand from a volume of 2.3 liters to a volume of 5.8 liters. During the process, 460 joules of heat is transferred from surroundings to gas. This question has us look at A, B, C. So we will be doing 3 parts to this question. A, how much work has been done if the gas expands against a vacuum? B, how much work has been done if the gas expands against a pressure of 1.3 atm? C, what is the change in the internal energy of the system? Question 7, Part A. How much work has been done if the gas expands against a vacuum? The key word in this question is vacuum. Vacuum is a condition, and the condition states that the external pressure is equal to 0. Okay, we know that if a gas expands against a pressure, then work is done. So we know that in order for work to be done, a gas needs to expand against a pressure. The pressure, we already stated, based on the conditions we were given, is Pxt is equal to 0. No pressure. So therefore, there is no work being done. Work is equal to 0 joules. We can also prove this by using the equation work is equal to negative P Ext change in volume times the change in volume. This is volume. We know that Pext is 0, but we weren't given the values for the volume, but we know if a constant times a 0 will always be 0. So therefore, work is 0 in units of joules. So 0 joules was done. Question 7, Part B. How much work has been done if the gas expands against the pressure of 1.3 atm? First of all, the equation we will be using is work, which is represented by W, equals negative Pext, which is the external pressure, times the change in volume. Change in volume. Okay. Now, let's see what values were given to us. We were given the pressure, which is 1.3 atm. And we were also, in the first question over here, we were given the volume initially and the volume final. So initial volume is 2.3 liters. And the final volume is 5.8 liters. So the final volume is 5.8 liters. Okay, so now that we have these values, we can plug them into the equation. So work is equal to negative pressure, 1.3 atm, times the change in volume. And the change in volume is the final volume minus the initial volume. Okay, so then we will put 5.8 liters minus 2.3 liters. We subtract this and get a 3.5 liters and negative 1.3 atm. Multiply them and you get a negative 4.55 liters times atm. Okay, good. Now, work is in units of joules, which is just J. And this, we have liters times atm. We need to find a conversion factor or equation, a ratio that has joules over L times atm. So we have 4.55 liters times atm times 1 joule over 0.00986 liters times atm. These cancel out and we get negative 460 joules. Question 7, part C. What is the change in the internal energy of the system? Delta U is a change in the energy, and energy refers to, energy is actually work and heat, which are two different kinds of energies. So the energy, of course, will be equal to the change in the work plus the change in heat, which is represented by Q. This is heat. Okay. We will refer back to the original question, and it says that during the process, 460 joules of heat was transferred from the surroundings to the gas. The gas is a system. And then we have the surroundings. And in the question it says that during the process, 460 joules of heat, Q, is transferred from the surroundings to the gas. The gas is in here. That means the system, the surroundings, did work on the system, which is a positive value. Okay, so now we have delta U is equal to 460 joules of heat plus work. And from the previous question for part B, we calculated that at the pressure of 1.3 atm, the work being done was a negative 460 joules of work. We can say it's negative. It's a negative value because the system did work. The system is the one that does work on the surroundings, so it's a negative 460 joules of work. Okay, so now that we have the value of work and the value of heat throughout the process, these add up to a 0 joules, which is the change in energy of the system.